Hi folks, Mr. Long here. I'm going to do a screencast on solving differential equations with exponential solutions. These are going to be what are called general solutions. So in other words, you're not going to have the constant of integration. And I guess maybe I'll start with just going over that again. So why is it that if we have the integral of, say, 2x equals x squared plus c. Why is that? Why do you get the x squared plus c? Well, and again, I think you know that, I should have put dx there. So why is it that you have x squared plus c? Well, let's see. If I have, there's x squared plus, say, 7, x squared plus 3, and there's x squared minus 5. So if I have the derivatives of each of those, the derivative of all of those is the same thing. It's 2x, right? So the integral of 2x dx is just x squared plus some constant c, because I don't know what the constant was. If I knew a specific point on the curve, then I could easily get it. Okay, that's where the c comes from. All right, so let's go to this example here, then, number 1. Okay, so this was the differential equation, dy by dx equals 2y. So this is all about separation of variables. Okay, so we want to separate our variables. And when we separate variables, what we're doing is getting the y's with the y's and the x's with the x's in the equation. So usually you're going to have to multiply by dx on both sides, right, to get rid of that dx in the bottom. So we're going to multiply both sides by dx. So here you'd multiply by dx on both sides. So that gets rid of that and come down to here and introduces that there. And we're going to also divide both sides by y, okay, to get the y over to here. So now we have dy over y equals 2 dx. Now in the next phase, we just integrate. So I showed the integral there, I showed the integral there. Doesn't matter if the 2's inside or outside. But now I need to integrate. So if I'm going to integrate, we know the integral of, by the way, dy over y, whoops, I just changed to 1 over y times dy. So that integral we know is the ln of y, and we know its absolute value, and we understand why. And then the integral of dx, well, that's a constant. So if the derivative was 2, what was the original function? 2x. But we also need a constant. Now, I could put a constant on this side as well, like call this c1 and call this c2, but then that just makes things more complicated than it needs to be. I just can have a constant on one side and call it c. Okay? Then, after that, what we need to do is, now we need to solve for y, because we don't write equations that say ln y. We write equations that say y equals. So what we have to do is, what's the inverse? I want to get that y by itself. So I have to do the inverse of ln y to isolate it for y. Just like if you had x to the 1/3 and you wanted to get x by itself, you'd have to do the inverse of 1/3 and put cube, and that would equal x. Well, it's the same thing over here. What's the inverse of ln y? It's e. So I raise both sides to the base e. Okay, so these become exponents. The left side and the right side become exponents. Ln of the absolute value of y is ln of the absolute value of 2x plus c. And here's where some exponent rules become important. So in this line right here, what I'm doing is I'm taking 2x plus c and turning it into c plus 2x. Am I allowed to do that? Yeah, that's just commutative property. 1 plus 2 is 2 plus 1. Then I can undo the exponent laws from this. So that's just e to the c multiplied by e to the 2x. So why did I change the order? Well, because I wanted the constant part to come first. Okay, I wanted the constant part to come first. Okay, so that becomes e to the c, e to some constant c multiplied by e to the 2x. Well, e to the c is like e to the 5, e to the 7, e to the 10, e to the negative 1. We don't know what it is because we don't have a point on the curve. But, so I can just say that e to the c is some constant c, and there's my solution to the curve. Okay, so y equals c e to the 2x is the solution for dy by dx equals 2y, which makes a lot of sense when you think about it, because y prime in this case is, what's the chain rule say? The derivative of 2x is 2. 2ce to the 2x. Remember that our y prime equaled double of y. Well, there's what y is worth, and then we have double that. Okay? So that's the solution. All right, let's look at our next one. dy by dx equals 2xy minus 8x. Again, the hard part here is how do I get all the y's on one side and all the x's on the other? Well, I have to gather the x's together. How do I do that? I do that by factoring. So what I did here is I common factored both sides. What did I common factor? The 2 and the x. So I common factored 2 out of that 8x and x. So I common factor that, and I end up with 2x multiplied by y minus 4. Now I have a factor here, which has only x's. I have a factor here, which has only y's. So what I do is divide both sides by y minus 4 and multiply both sides by dx. Okay, so I do that. Then I'm left with this. So I've got dy over y minus 4, and over here I've got 2x dx. Now I do integrals. Okay, I'm going to integrate that, and I'm going to integrate that. So once I have the integral of 1 over y minus 4 dy, and 2 times x dx, the integral of, I should say, then I integrate. Well, I have to do the integral of 1 over y minus 4. The integral of 1 over y would just be ln y. So the integral of 1 over y minus 4 is just ln of y minus 4, but in absolute value terms, because I don't know if it's the left or right branch of 1 over x, or 1 over y minus 4 that I was working with. Now this is a little bit easier. I know the antiderivative of x is x squared over 2, x to the n plus 1 over n plus 1. Right, that's what this is. And then the 2 over 2, well, that divides out to give me 1. And I have to add the constant of integration there, c. So, what's the inverse of ln? E. So I raise e to the y minus 4 in absolute value terms. Now, I don't know if I've got the positive y minus 4 or the negative y minus 4. I don't know that yet. And I won't, because it's called a general solution. I don't have a specific point to work with. So then I have e to the x squared plus c. And then I'm going to change the order here of this. And it's going to become e to the c times e to the x squared. E to the c is just like e squared, e to the 5, e to the 10. It's just a constant. So I write c. And then I have multiplied by the x squared. Now, here, if I assume there's no, what I'm going to do is, in this case, as I did in the example before, I assume that there's no, the absolute value gives us just the positive. I'm going to add 4 to both sides. And y would end up equaling x squared plus 4. Okay, folks? So ce to the x squared plus 4. And that is the solution to that. That's the general solution of that differential equation. And hopefully, now I guess the other way that we could write this is y minus 4 equals plus and minus ce to the x squared. I hadn't thought about that. That's also another way to do it. So I could write it as y equals plus and minus ce to the x squared plus 4. And we won't know if it's plus or minus unless we had a point. Which reminds me, then maybe up here, this one here, sorry, in the first one, Could have been plus or minus there. Okay. So, those are our two solutions. So hopefully you look things over and rewind, review to help you understand this. All right, have a good day.